This chapter is chapter 5 on motion. This is our introduction to physics. So we are going to be switching from the chemistry science to the physics science here. It is a short chapter, but it is very important. Everything you learn in this chapter is going to be applied into other chapters. So you need to know this in order to understand anything else in physics. So it's going to start off with motion, and we're going to go into speed, velocity, and acceleration. These three topics are extremely important, and even though there doesn't seem like a lot of notes on this, it is a bit confusing and abstract. So if you do need to watch these a couple times, that's all right. So first we're going to start with motion, and we're going to start with simple definition, and that's going to be asking the question, are you moving? This is a very abstract question to think about. Individual parts of your body are always in constant motion. You have blood flowing through you, so is that considered you moving? You are breathing right now. Does that consider motion? Uh, we're going to define motion. So if an object is moving, it's going to be changing its distance relative to another object. So you do need two objects here, one of which we are going to consider as not moving, and one we are going to consider as having the possibility to move if the distance is changing. That is going to be very, very important depending on how you pick your reference points, or what are these two objects you're going to pick. If object 1 is moving further away from object B, then object B is your reference point. Object B is not moving. So if I'm on a train, and you look at this train, and this train is coming up on a station, if my reference point is the station, then the train is decreasing its distance towards that station. Therefore, I can say the train is in motion. However, if I pick my reference point as the train, then I can say that the station is decreasing its distance towards the train, and therefore the station is in motion. It depends on what reference points you pick. So it's very important to choose a reference point that is widely considered as stationary in many contexts. You never hear about how the station is moving towards the train. You hear about how the train is moving towards the station. Either statement is correct. It just depends on what reference point you choose. And as a rule of thumb, most people, and in most contexts, tend to choose objects that people think of as stationary, such as trees. Trees, you think of stationary. Signs, you think of stationary. And other objects, such as animals like us that move around, are not. So example again, if I pick a tree as a reference point and I'm walking towards this tree, then I am in motion. If I choose me as the reference point and I put my perspective on the tree, and I am in the tree and I are getting closer, the distance is decreasing, I can say that the tree is coming towards me. It all depends on that reference point. Motion is relative, and that is a very strange concept to wrap your head around. So please, if you have questions, make sure you're asking them. Uh, Choosing a reference point, again, you want to choose things that are considered to be stationary by many people, trees, signs, buildings. But what if you do pick a reference point that's moving? If you do, you get confused. Your brain doesn't necessarily register correctly. You don't see things the way most people would, which is kind of a unique experience. The one time that I think you probably experienced picking a bad reference point is if you're ever on a bus next to another bus, and all you can see out the window is that bus, so you're picking that bus as a reference point, and all of a sudden you get this feeling that you're moving backwards for a split second because your reference point, the other bus, decided to drive forward away from you. And you get this weird sensation that you're moving backwards, but really you're the stationary object and the other bus is moving forward because you picked a bad reference point. But because it's relative, you can actually argue that you were moving backwards. It is kind of a unique thing to think about. So motion is relative. As a whole, like as a whole, depending on you, you can think, okay, if I pick my reference point as the door and you're just sitting here watching this video and the door is over there behind you, is the distance between me and the door changing right now? No, it is not, so therefore I am not in motion. However, if I pick my reference point as the sun, I know that the Earth is moving 30 kilometers per second around the sun. Therefore, in relative to the sun as my reference point, I am in motion, even though I'm just sitting here. It doesn't necessarily you see that all the time, but it depends on your reference point, your relative, the relativeness of the motion here.